Hi, welcome back. The GOM ScanCobot is your collaborative inspection system. With collaboration or working together, we mean taking over work from you. I will show you how the virtual measuring room in the software plays a crucial role here. Programming the robot is done entirely in the software. No robot control panel or robot in hand is needed. The best scanning positions for the ATOS Q are defined by its GOM Smart Teach functionality. The way how we start depends on if we have a cut design available or not. Let's first have a look on this part, for example, and let's see how we work in the software if we don't have any cut data. Having no cut data, we need to give the software an idea of the size and the shape of the part. For that, we define the dimension of one of these geometrical shapes where our part fits best into. Half sphere or box for box-shaped parts, a cylinder for long parts, or a disc for flat parts. The amount of measurement positions we select depends on the complexity of the part. Simple shapes require fewer positions of the sensor. Complex parts will require more viewing angles. With the envelope of the part defined, the teaching software creates the scanning positions. The virtual measuring room will now take care that the robot does not enter the envelope you created. With a few mouse clicks, we created a safe robotized inspection process. In case we have a cut file, we have a lot more information about the exact shape of the part. Using cut data, a minimum number of positions will be defined to scan a maximum of areas on the part. This will be our new test part, a 3D metal printing part. Before printing more of these, we would like to know if this is the first one within the tolerance. Let's have a look in the software. So I need to start with uploading the cut data of our part. Here we also have inspection data available. So if you have PMI information on what has to be inspected and which tolerances have to be used included in the cut data, we will use them too for the programming. To give you an idea on the ease of defining these inspections, I will add this hole here and inspect it for position and size. For this part, next to the specific inspection item, I would also like to have an overall view of the shape of the part. For this, we request a color plot of the entire shape. Smart Teach will now use information for features to be inspected and our overall color plot to define the minimum number of positions needed. In less than a minute, we have a robot program. We can further optimize it by defining the fastest route along the positions. If needed, the optimization will automatically create some intermediate positions for the robot to avoid any collision. So the virtual program is ready and can be moved to the GOM ScanCobot. With our program ready, we can start the inspection process. During the scanning process, the mesh is being built up using the minimum number of positions used for the ATOS Q. The virtual measuring room in the GOM software took all over the robot programming from me. It even calculated the minimum scan positions. Easy, fast and safe. Look like he's ready. Let's have a look on the results. The scan result is a highly detailed mesh including all the inspection features and the color plot of the entire shape of the part. If your inspection template includes reports, a simple recalculation of this part generates all the reports with another simple mouse click. This was an introduction of Smart Teach in the GOM Inspect Suite software. We had a look at how to measure single parts. From 2020 onwards, the software also supports an easy workflow to scan multiple parts in one program. The ATOS Q and GOM ScanCobot, a really smart solution.